in subject of concrete technology, in that module 3 hardened concrete. Now we will discuss module 3 hardened concrete. In that the first topic will be factors influencing the strength of concrete. Factors influencing the strength of concrete. So there are many factors which influence the strength of concrete. This may be quality of raw materials, water cement ratio, coarse or fine aggregate ratio, aggregate cement ratio, age of concrete, compaction of concrete, temperature, relative humidity, curing. These all are the factors which influence the strength of concrete. So in that today we will discuss about three factors which are cement, water cement ratio, gel space ratio and maturity of concrete. Okay, so in that the first one is water cement ratio. The strength of concrete primarily depends on the strength of cement paste. The strength of concrete primarily depend on the strength of cement paste. So the strength of the cement paste depends upon the dilution of paste. That is dilution of paste. That is the thing. But it can be said that the strength of the paste increases with the cement content and decreases with the air and water content. That is dilution. If it get diluted, if it get properly diluted, then it will gain the strength. So the strength of the paste increases with the cement content and decreases with the air and water content. If there are more air voids, then the strength will lose. Okay, so here you can see the graph of water cement ratio versus compressive strength. So there are different types of concrete are compared. See, you can see the vibrated compaction concrete, hand compacted concrete. Okay, so here you can see this is the concrete of vibrated compacted concrete and hand compacted concrete. See, by the relation between the water cement ratio and the strength of concrete as shown in this figure, so it can be seen that the lower water cement ratio could be used when the concrete is of vibrated to achieve the higher strength. Here, as I told, here is the concrete which is compacted by vibration. Okay, so to get the higher strength for the vibrated concrete, the water cement ratio is used very less, and comparatively high water cement ratio is required when the concrete is of hand compacted. When the concrete is of hand compacted, then the comparatively higher water cement ratio is required. So in both the cases when the water cement ratio is below the practical limit, the strength of the concrete falls rapidly due to introduction of air voids. In both the cases when the water cement ratio is below the practical limit, the strength of the concrete falls rapidly due to introduction of air voids. As I told, if the air voids are more, then there will be a loosening of its strength. So that's why in the mixing of concrete or cement paste, we should mix in such a way that there should not be any air bubbles or air voids, or it may be water voids. Okay, so that is the one of the important factor which you have to consider while mixing, that there should not be any air voids. Even for calculation purpose also, you should consider the air voids in the concrete. Okay, so for a given cement content, even here one more point which affect by this water cement ratio is workability. One more point which affect by this water cement ratio is workability, and workability also which influence the strength factor. See, the workability of the concrete is reduced if the water cement ratio is reduced. Workability of the concrete is reduced if the water cement ratio is reduced, because when the lower water cement ratio is used, it means the less water and more the cement, and lower the workability. Workability lower means it will be difficult to placing and compacting of the concrete. It will be difficult to placing and compaction of the concrete. So however, if the workability becomes too low, the concrete becomes difficult to compact and the strength reduces. As I told, it will become difficult to compact and the strength of concrete reduces. So for the given set of the materials and the environment conditions, the given for the preparation of concrete, the given set of the materials and the surrounding environment conditions, the strength at any age depends only on the water cement ratio. The strength at any age depend on the water cement ratio. Providing full compaction can be achieved. Okay, this is about water cement ratio. Next we'll go through the gel space ratio. Gel space ratio is defined as the ratio of the volume of hydrated cement paste. The volume of hydrated cement paste to the sum of volume of hydrated cement paste and the capillary pores. Pores are the thing, but the voids only. That's why it is called as gel and space ratio. Gel space ratio. That is the thing, but the volume of the hydrated cement paste. That's why it is called as gel. Gel is here. Gel means hydrated cement paste. That is the thing, but cement and water. Okay. So hydrated cement paste to the sum of total volumes of the hydrated cement and the capillary pores. That is called as gel space ratio. So many experiments have been conducted on this by the different scientists. So Powers experiment showed that the strength of the concrete bears a specific relationship with the gel space ratio. The strength of the concrete bears or depend on the specific relationship with this gel space ratio. He found that the relation to be 240 into x cube. The relation to be 240 into x cube, whereas x is the gel space ratio. Here x is the gel space ratio and 240. The 240 is represents the intrinsic strength of the gel in MPa, that is in Newton per mm square, for the type of cement and specimen used. For the that is depend on the type of cement and specimen used. Okay, and the relationship between the strength and water cement ratio will hold good primarily for 28 days strength for fully compacted concrete. You all might have known that when you test the cubes or cylinders or beams, mainly for the 28 days curing. Okay, even we conduct the curing for normally 21 days. If it is highly concrete, then we can go for 28 days also. So for in the relationship between, in case of water cement ratio, that the strength will hold good primarily for 28 days in case of water cement ratio. But whereas in relationship with the strength and gel space ratio, it is independent of age. It is independent of age. Here the days cannot matter here. So the gel space ratio can be calculated at any age for any fraction of hydrated cement. That's why the gel space ratio can be calculated at any age and for any fraction of hydration of cement. So this is the main difference between water cement ratio and gel space ratio. Once again I'll tell, the relation between the strength and water cement ratio will hold good primarily when you conduct the curing for 28 days, that is for fully compacted concrete. Okay, but whereas in case of gel space ratio, that is in relation between strength and gel space ratio, it will be independent of age. The age does not matter here. That is, the gel space ratio can be calculated at any age and for any fraction of hydration cement. Okay, hydration of cement. This is the gel space ratio. Next we'll go through the maturity concept of concrete. So normally when dealing with the curing and strength development of concrete, we only consider the time aspect. As I have just now I have told 28 days curing, so 21 days curing. So when dealing with this curing and strength of the concrete, strength development of concrete, we only go through the or consider the time aspect, but it is also important to consider the temperature during the early period of hydration that influence the rate of gain of the strength of concrete. So it is also important to consider the temperature during the early period of hydration, that is in the period of hydration of cement carrying out. In that period it is important to consider temperature also, which influence the rate of gain of strength of the concrete. It means it will gain the strength if you consider temperature also. I'll tell how. See, since the strength development of concrete depends on both the time and temperature, so it can be described that the strength is a function of summation of product of a time and temperature. When you are considering the time and both the time and temperature as the strength development points, when you are considering both the time and temperature as the strength development points, so it can be said that strength is a function of summation of the products of time and temperature. Okay, so this summation is called as maturity of concrete. This summation is called as maturity of concrete. The strength is a summation of product of time and temperature. Okay, based on time and temperature the strength is going to define. So this summation is called as maturity of concrete. So that you can write maturity equal to summation of time into temperature. You can write expression as maturity equal to summation of time into temperature. The temperature is reckoned from an origin lying between -12 and -10 degrees Celsius. That is nothing but basically the temperature is counted between -12 and -10 degrees Celsius. But when the experiments were conducted on this temperature, so it is found that hydration of concrete continues to take place up to about -11 degrees Celsius. When the experiment conducted, it was found that the hydration of concrete continues to take place up to about 11 degrees Celsius. So therefore this -11 degrees Celsius, this -11 degrees Celsius is taken as datum line for computing the maturity. When you are calculating the maturity concept, then this -11 degrees Celsius is used as the datum line. -11 degree centigrade is used as the datum line for the computing the maturity. So the maturity is measured in degree centigrade hours, that is degree centigrade hours or degree centigrade days. So basically the maturity is measured when you want to measure the maturity of the concrete. It will be measured in degree centigrade hours or degree centigrade days. It can be called it as unit of a maturity. Okay, so that is degree centigrade hours or degree centigrade days. See here the graph is shown between the accelerated strength and the strength of normal curing, that is in Newton per mm square. So this figure shows that the strength of plotted against logarithms of maturity gives the straight line. That is here to compute the maturity, here a sample of concrete cured at 18 degrees Celsius for 28 days is taken as the fully matured concrete. Here to compute the maturity, so they have taken here a sample of concrete which is cured at 18 degrees Celsius for 28 days. Okay, and taken as the fully matured concrete. So it can be calculated as, or it would be equal to 28 into 24 into bracket 18 minus 11, that is equal to 19,488 degrees centigrade hours. I'll tell you here 28 is the total 28 days curing time, that is the 28 into 24 is the hours, because you are calculating here in degree centigrade hours. So 24 is the hours into 18 is the the sample of concrete cured at degree Celsius, that is 18, and minus 11 will be the datum line. As I have told, the minus 11 degree Celsius is taken as the datum line for computing the immaturity. So that is the minus 11. So it will be equal to 19,488 degree centigrade hours. Okay. However, but in standard calculations, the maturity of fully cured concrete is taken as 19,800 degree centigrade hours. For the standard calculation, the maturity of fully cured concrete can be taken as 19,800 degree centigrade hours. Okay, this is about maturity concept of concrete. Thank you. It is getting stuck.